What if I told you one of the fastest ways to destroy an off-grid system isn't overload, bad wiring, or even poor batteries? It's inverter overheating, because heat doesn't just reduce performance. It slowly breaks down the internal components until failure becomes inevitable, often without obvious warning until it's too late. An inverter is not just an electrical device, it is a high-speed power conversion system. It's constantly switching, regulating, and transforming energy, and every bit of inefficiency inside it turns into heat. If that heat is not controlled, it builds up, stresses components, and eventually forces the system to shut down or fail. At the beginning, you need to understand a simple truth. Heat is the natural byproduct of power conversion. No inverter is 100% efficient. Even high-quality systems operate around 90 to 95% efficiency, which means 5 to 10% of all energy passing through is lost as heat. In a high-power off-grid setup, that heat becomes significant very quickly. Imagine a 3000 W inverter running at full load. That's around 150 west of heat being generated continuously inside the unit. That heat has to go somewhere. If it can't escape, it builds up. This is where overheating begins, not as a sudden event, but as gradual thermal buildup. The most common cause of inverter overheating is poor ventilation. Many systems are installed in enclosed spaces, like cabinets or sheds. Without proper airflow, hot air cannot escape, cool air cannot enter, and internal temperature rises continuously. Even the best inverters rely on external airflow to maintain safe temperatures. If you trap heat around them, performance will drop regardless of quality. Another major cause is high continuous load. Running an inverter close to its maximum rating for long periods generates significantly more heat. Over time, this leads to thermal stress on internal components, reduced efficiency, and increased likelihood of shutdown. A properly designed system avoids this by allowing headroom, not running the inverter at maximum capacity all the time. Ambient temperature matters too. If your inverter is in a hot space, like a shed in direct sunlight, the starting temperature is already high. Another key factor is dust and airflow obstruction. Over time, dust can build up inside cooling vents and on internal components. This reduces airflow and traps heat inside. Fans become less effective and cooling performance drops even if everything else is working correctly. When internal temperature reaches a critical level, the inverter will reduce output or shut down completely as a safety mechanism. Overheating doesn't just cause shutdowns, it causes long-term damage like capacitor aging and insulation breakdown. Even if the inverter keeps running, poor wiring can also contribute. If cables are undersized or connections are loose, they create resistance, which generates even more heat. A proper setup includes open airflow, clearance for heat dissipation, and installation in shaded or temperature-controlled areas. Positioning matters more than people think. Even moving an inverter from a closed box to an open space can dramatically reduce temperature. Inverter overheating is a system design problem. It reflects load levels, airflow design, environment, and overall system balance. Heat is the invisible force that determines how long your inverter will last. A cool inverter is a reliable inverter. If you want more deep breakdowns like this, make sure to subscribe to my channel, Off-Grid Life Tech.